Hello, and welcome to a special episode of Becca Breaks It Down. In this episode, I am continuing our discussion on applications to compound interest. So, you may recall from our previous lesson, compound interest, I can use this formula here. So, this formula will tell me the balance B of like an investment. Okay, where P is representing like the original amount that I invested, R is that nominal rate, so that's the stated rate, N is the number of compounding periods, so how often the interest is being like calculated throughout the year, and T is representing the number of years. Okay, so R is that nominal rate, it's that stated rate. What we saw in the previous episode was that the more often that interest is like compounded and calculated throughout the year, the more money you will ultimately make in the end. And that all has to do with the effective rate. So the nominal interest rate is what's stated. The effective rate is like the end result, like what you're getting in the end, like truly what is your like actual interest rate. Okay, and we can find that effective rate, also known as the APY, by doing this calculation here. So we have 1 plus r divided by n raised to the nth power. From there, we're going to subtract 1 and multiply by 100%. So basically, this is the equivalent of going base minus 1 times 100 that we've done previously in our exponential function formulas, because like the base of this compound interest like formula is, that part. Okay, like if I were to write this more simply, balance equals the principal times b to the t power. B is the 1 plus r divided by n raised to the nth power. Okay, and as you know, the effective rate can be used to compare investments. So we're just going to like take a look at some other applications that use these formulas. Right. So in this problem here, it says at the beginning of the year, you deposit P dollars in account paying a nominal rate of 4% per year, compounded quarterly. By what factor does P grow in 3 years? Okay. And so like based on what they gave me here, like they said you deposit P dollars. So they didn't really give me an actual dollar amount, but this formula for balance does tell me does involve that initial investment of P dollars. The nominal rate, that's R. Whenever I use these formulas, I turn R into a decimal, so R is going to be 0.04. Compounded quarterly means N is equal to 4, and then 3 years time, we're talking T is 3. Now, what's interesting is that this problem asks, by what factor does P grow in 3 years? Well, remember, the factor, the growth factor, is this part of our function right here. Okay, because I'm taking P times that to the T power. So that's really all I care about in this problem is like that factor, what it is in 3 years' time. So what I'm going to do is I'm basically going to use this part of my formula. So I'm going to have like 1 plus, and then my R value is 0.04 divided by 4. And then I'm going to raise that to the 4 times 3 power. Okay, so 4 times 3, so that's 12. All right, and I'm just going to calculate this because that's the factor, because we're talking P times this. And whenever you multiply two things together, those two things are called factors. So P is a factor, and then the rest of this formula is the other factor. So that's simply what I'm trying to figure out. And so I get that my factor, my growth factor, is approximately 1.127. And that's what it's asking for. By what factor does P grow in 3 years' time? And it's going to grow by a factor of 1.127. Okay, which really, like, what does that even mean? So to kind of like illustrate what exactly this means, if that's the growth factor, then the APY, the effective rate, is going to be like 12.7%. So like my investment's going to grow by 12.7% in those 3 years' time. Okay. In this problem here, it says an investment decreases by 50% over an 8-year period. At what effective annual percent rate does it decrease? Okay. So if we think about what do we know here, okay, it says an investment decreases by 50%. So if I originally invested P dollars, like that's my initial investment, right? And this decreases by 50%, what would be the balance after that decrease? Okay, so I'm taking like 100% of like my original investment and I'm subtracting 50% because it decreased by that. So that means my balance is going to be 50% of my original investment. Okay, so what that means here is that my balance is 50% of my original. So that can be represented by 0.50 times P, because P was my initial investment. Okay. As for the rest of this, what are some things that I know? I don't know R. And as far as N goes, they really didn't mention quarterly, monthly, or anything. So I'm just going to go with like an N value of 1. And then the last bit that I know is that it's an 8-year period. So that means T is 8. So I've got 1 plus R over N. Well, N is 1. So I'm just looking at 1 plus R raised to the N times T power. Well, T here is 8. So this is what we're looking at. Let me just erase some of this stuff here that's in the way now, our thought process. Okay. So what do you notice about that equation that we have written so far? Yeah, both of them you're multiplying by P. So on the left side, I have 0.50 times P, and on the right side, I have P times 1 plus R to the 8th power. So really those P's completely cancel out because you can divide both sides by P, okay? So now if you take a look at the right side, I have 1 plus R to the 8th power. Now how can I undo raising something to the 8th power? Okay. So it's going to sound weird, but like I can take the 8th root because you know how like if we have something squared, we can take like the square root of it. Well, if I have something to the 8th power, I can take the 8th root of it to undo that. All right. And so what we do like on our calculators is we are actually going to take both sides here to the 1/8 power. Okay. Because 8 times 1/8 is 1, so that does the same thing. So over here, I'm going to do the same thing. I'm going to take 0.50 to the 1/8 power. All right. Now, clearly, I want to use a calculator for that, and I did. And I got like approximately 0.917. And so 0.917, this is equal to 1 plus R. Okay. So then I just simply need to figure out like what is R. So I can subtract 1 from both sides. And I get negative 0.083. So this is R, and of course I'd want to turn it into a percent. So if I multiply it by 100, that'll turn it into a percent. So I end up with 8.3% as that effective annual percent rate. Okay. And so there you have it, just a few more examples involving applications with compound interest and using that formula. And that's how Becker breaks it down. Have a nice day.